Good day. We are completing your kinetic molecular theory notes. You would have copied the 5 points at the top of your sheet of notes that were blank. And then there were 3 rectangles at the bottom, and this PowerPoint is going to help you fill in those assorted beasties. See what my noise is. Oh, no, can't have that. So, kinetic means moving, molecule means little lump or small particle. So it's the theory of moving little lumps. And Richard Feynman, who had a storied career in physics, all the way from World War II up until the Challenger disaster in 1986, said this is one of the most important theories of all time, and this is relating to all of science. In fact, he said if there was one piece of information we had to leave behind, if all other information has been wiped out, this is the theory to leave behind because it would help people understand the behavior of matter. So these things you already copied down. All matter is made of tiny particles. The particles are in constant motion. So the tiny particles, molecular, constant motion, kinetic. We said there's empty space between the particles, and the particles in empty space are insanely small, so small they cannot be seen, even with a microscope. Number 5, heat makes the particles move faster, and a lot of our activities are going to be illustrating that point. So we're going to look at solids, liquids, and gases, and in fact, in the coming slides, we're going to look at them gases first. You're going to sketch what the particles look like in each state, and you'll copy the description to the left or the right or both of the rectangles. So here we go. Here's our first rectangle, and you can see you're going to draw in these 7 dots, and you want to draw them in approximately this size, and we want all of those dots to be the same size. And now we're going to say 5 things about them. 1. In a gas, the particles move really rapidly. They can collide with the outside of their container. They create pressure that way. Gases are mainly empty space. Gases will completely fill their container. Gases do not have constant volume. We can change their volume very easily. They are what we call compressible. We'll get to that later. And our 5th point is gases do not hold their shape. It's very easy to change their shape, and that is in part because they fill their container. So if I've gone too quickly, you can pause the video and you'll copy these things to the left and or the right of your diagram. Next, we're going to look at liquids and look at 5 points related to them. Some funny V's in there, they should disappear. So now we have to put all these particles, notice they're all the same shape or same size, and they are close together, way closer than in a gas, but they are also chaotic. So they're going to move more slowly, but they can still move freely. So they're free to move on their own. There's not a lot of empty space between the particles. That makes them incompressible. Liquids are going to fill the bottom of a container normally. So you think about pouring a glass of orange juice. It's going to fill that bottom. Not completely filled the way a gas would. Liquids have constant volume. They're not compressible because the particles are close together. And liquids do not hold their shape because their particles are not locked together. Again, if I've gone too quickly, which I likely have, pause, copy the diagram, copy those 5 points. Now we look at solid. Solid, again, our particles are all the same size, but now they're very organized. They look like they could be the military marching along down the middle of a street. Every particle organized in a position in a row. In fact, the particles are locked together, but they are still able to move, but their movement is just vibrations. So particles are locked together. Very little empty space between the particles, just like in a liquid. The particles can only vibrate, that means move back and forth repeatedly. Solids have a constant volume because their particles are close together. And solids hold their shape because the particles are locked together. So make sure you get this all copied out for your introduction to the kinetic molecular theory. Again, pause since I've likely gone too quickly. We have a few more slides. So this is comparing gases, liquids, and solids side by side. This is showing the length of the arrow suggests they're moving faster. And you can see when they hit the edge of the container, they bounce back in. That's what gases do. Liquids do the same thing at the bottom of the container. And here the solids are all organized and they're just a bunch of vibrating particles. Here are notes that you have to completely copy. And it says fluids. When people think of fluids, they think of liquids. But gases are also known as fluids. They're called fluids because they can flow. Why can they flow? Because their particles are not locked together. The particles can move on their own. So the word we like to use for fluids is they are pourable. You can pour a fluid. In fact, you can pour a gas, believe it or not. So we're pretty well wrapped up our notes on the KMT, and now the activities and worksheets are going to try to illustrate key points of the kinetic molecular theory. Make sure you have all these notes copied and that you understand them, and if you don't, ask for help.